Okay, so today we're going to talk about the last conic section, which is parabolas. And just like ellipses and hyperbolas, there is an equation, actually two equations, associated with parabolas. So I'll just tell you what those are. So first of all, we have the equation y minus k is equal to 1 over 4p times x minus h quantity squared. This is one equation of the parabola. There's another one, and I'll tell you what it is in a moment, but let's just start with this one here. Now, you've seen parabolas before. They are just graphs of quadratic functions, and if you look carefully at this equation, that's what this is. Despite the h, the k, and all that stuff, you can see that fundamentally this equation could be written in the form y equals something involving x squared. So this is just a regular old-fashioned quadratic function, and the graph is a parabola. But it's written in a particular way, quite different from what you've seen before, to illuminate certain features of the parabola. So what are those features? So first of all, unlike the other conic sections, parabolas don't have a center. They just have a vertex. So I'll start by plotting the vertex. Now, the vertex is located at h comma k, very similar to the centers of ellipses and hyperbolas. And the graph of a parabola, you know what it looks like. It looks something like this, or at least it can look something like that. It depends upon the values of the constants inside of this equation, but roughly that's what a parabola looks like. And you've seen this before, but I just want to add a few other things to this graph. First of all, there is a line sitting here, which this line is not actually part of the graph of the parabola, but it has a certain significance for the parabola, and I'll tell you what that is in a moment. But for now, I just want to tell you that the name of this line is the directrix. Okay? And just like ellipses and hyperbolas, parabolas also have this funny point, a focus, and like usual, the curve kind of hugs the focus. So the focus would be right here in that case. Okay, so just a couple of things. Looking at this equation, you can see that besides the usual x and y, there is h, k, and p. You've already seen that h and k determine the coordinates of the vertex, so that just leaves p. What does p represent? P is this distance right here, essentially. It's the distance between the vertex and this funny line, the directrix. Alternatively, it's also the distance between the focus and the vertex. So this distance right here, that is also p. All right. So one more thing, or a couple more things to say about this. First of all, there is sometimes another line which is drawn in this diagram. Again, not actually part of the parabola itself, but, you know, it's just drawn. This line here, you might remember from Algebra 2, this thing has a name. It's called the axis of symmetry. And it's not actually part of the graph, but it's just a line which I suppose you can say the graph is symmetric about that line. All right, so a few more comments. First of all, you might remember that parabolas can be shaped like this. They can open up, or they can be upside down and shaped like an upside down U. So what determines whether they are right side up or upside down? It turns out it's the sign of p. So if p is positive, then the graph looks like this. It opens up, and if p is negative, then the graph opens down. So just I want to make a comment about these lines here, the directrix, which is this horizontal line, and the axis of symmetry. These are horizontal and vertical lines, and I will often ask you to find the equations of those lines. I'll give you some parabola and I'll say, find the equation of the directrix. You certainly know how to find equations of lines. I just want to remind you that horizontal and vertical lines, their equations have a particular form. They're a little bit different, right? A horizontal line like this one is always of the form y equals just some number, right? It's always just y equals a number, like y equals 5 or y equals 7. There's no x in the equation. And for this vertical line here, remember vertical lines are, their equation is of the form x equals just some number, right? There's no y involved in the equation. So vertical lines have the form, their equation has the form x equals some number. So just be aware of that. In this situation, if I asked you, find the equation of the axis of symmetry, your answer would be something like x equals 6 or something like that. Okay, so I want to, as usual, talk a little bit about the geometric aspect of the parabola, which you probably have not seen before. So, and as usual, it has something to do with the focus. So the sort of geometric interpretation of the parabola has something to do with this line here, the directrix, and this point here, the focus. So here's what it is. If you pick any point on the parabola, say this one right here, okay? Look at the distance from this point to the focus. That would be the length of this line right here. Look at the distance from this point to the directrix. That would be the length of this line right here, and it would be perpendicular to the directrix. Now, I didn't draw this parabola perfectly, obviously, but if I had drawn it correctly, perfectly, then what you would see is that these two line segments are congruent. They have the same length, okay? So if you pick any point on the parabola, then that point's distance to the focus will be the same as its distance to this funny line, the directrix. So again, if you pick any other point, here's some other point, look at the distance from this point to the focus, look at the distance from this point to the directrix, and what you'll find is that those two line segments have equal length. So one way of talking about the parabola, if you like, is if you give me a line, that's the directrix, and if you give me a point, which we call the focus, then the parabola is the set of all points which are equidistant between this line and this point. So certainly, for example, the vertex is equidistant between these two things, but then so are all these other points, and the parabola is exactly the collection of all such points. So that is a geometric interpretation of the parabola, as opposed to the algebraic interpretation, which is just the set of points satisfying an equation of this form. Okay, so I told you that there are two equations of the parabola. This is the first one. The other one is obtained basically by switching the x and y terms around. So let's see what that looks like. So the other equation is x minus h is equal to 1 over 4p times y minus k quantity squared. All right, so that's the same equation, but with the x and y terms switched around. Notice, by the way, that regardless of where x appears, h is always the thing associated with x, right? It's x minus h right here. It doesn't matter whether x appears, second or first. H is always the number being subtracted from x. Keep that in mind, because a lot of times students think, oh, h is the thing that appears first. Well, in this equation, it's not. Here, h is the thing that appears on the right-hand side of the equation. Just remember that h is always associated with x, and k is always associated with y, regardless of where those variables appear. Another thing, while I'm at it, I want to point out, unlike the other conic sections, parabolas, only one of the terms are squared, right? Only the x term is squared, not the y term, and that's quite different from the other conic sections. Okay, so what's going on with this form of the equation? You can probably already guess. A parabola in this form is a sideways parabola. So in this case, the directrix would actually be a vertical line. I don't know if you can hear that beeping. There's construction going on at the school, so that's fun. So the directrix would be a vertical line, and the focus would be perhaps over here, and the graph would be something like this. The vertex is right here. Just as before, the vertex is still located at h comma k. That hasn't changed. And just like before, this distance right here is p, and this distance right here is also p. Everything's the same, and you've got this axis of symmetry, although the axis of symmetry is now a horizontal line. And the only other thing to say about this is that, this parabola can open to the right, or it could open to the left. And that is, again, determined by the sign of p, whether p is positive or negative. So if p is positive, then the graph opens to the right. And if p is negative, then it opens to the left. Okay? Right. So that's parabolas. I just want to sort of say something cool about these things before I do some examples. A really interesting geometric feature of parabolas, and proving this, I know how to prove this using calculus. I don't know if it can be proved without calculus, probably, but you'll just have to take my word for it. If you have a parabola, let's say that the focus is right here. Imagine that you have parallel light beams coming in. So maybe the sun is shining down, and you have a bunch of light beams coming in like this, and they're all parallel to one another, coming straight down. It turns out no matter where they hit the parabola, they will bounce off and go directly to the focus. So you could come in here, and you'll bounce off this way. Now this is really useful because, for example, if you want to build a satellite, what you do is you make basically a big cup shaped like a parabola, and then you put your receiver right here. And what this does is it scoops up all of the electromagnetic radiation, namely light, radio waves, whatever other kind of wave. It scoops up a big chunk of electromagnetic radiation and sends all of it to this one point, which can then be measured. So it's a way really of amplifying information being radiated in from space. If you run it in reverse, it's how you can make a spotlight or certain kinds of flashlights. If you make this a light bulb and you actually send the light beams out this way, then they will all be reflected and come out parallel to each other, shooting straight out. As opposed to, normally a light source just radiates outward radially, right, with spherical symmetry. Well, if you want to make a spotlight, this is how you do it. So lots of really interesting and direct applications of parabolas. And, if you want to build one of these things, you have to know where the focus is, right? Which means you have to use this mathematics. You have to look at p and blah, blah, blah. Okay, anyway, let's do some examples. So just a couple of examples. So let's talk about what do we want to do? Let's do the following. So let's say graph, let's say y minus 3 quantity squared is equal to 8 times x minus 2. And I want to graph this thing, and I also want to find the focus and the directrix. Okay. For one thing, what I would point out is that this equation, as it's currently written, doesn't actually look like the equations that we have. Not really, as you can tell. I mean, does it really look like this? Not exactly. Does it really look like this? Not exactly. But what I do want you to notice is that it is the y term which is being squared in this equation, right? It's the y term which is being squared, which means that it probably matches up with this form, right? Notice that the y term is being squared here. But of course, this equation doesn't quite look like this yet, but we can make it look like this. What I want you to notice is that, in this standard form, the linear term, the x minus h, is by itself on one side of the equation, and the squared term has a coefficient in front of it, the 1 over 4p. So in order to interpret this equation, finding hk and p, you should really begin by putting it in the standard form. And I can accomplish that by, first of all, as I said, the linear term, the x minus h, shouldn't have a coefficient in front of it, so I'll divide both sides by 8. I have 1 over 8, quantity y minus 3 squared is equal to x minus 2. Now this looks a lot more like our equation. I suppose technically in this version, the linear term is on the left-hand side, and the right-hand side, if you really like, you can, just switch the two sides. X minus 2 is equal to 1/8 times y minus 3 quantity squared. Okay, so now you can really, compare these two things, right? And you can see that they're the same. And now we can identify, all of the parameters h, k, and p. So, right, so in order to make this expression match up with this one, we would need h to be equal to 2, right? K should be equal to 3. And what about p? Well, if you notice, the coefficient in front of the squared term is 1 over 4p. If 1 over 4p is equal to 1 over 8, well, then that means that p is equal to 2. You can probably just see that, by eyeballing it, that p should be equal to 2. But sometimes you can't tell what p should be just by looking at it. So I'm going to show you kind of like a more rigorous way of finding p. So, if you know that this coefficient should be equal to this one, so you just write that down as an equation. 1 over 4p is equal to 1 over 8. And you can solve this equation for p. Sometimes people sort of forget how to do that. The problem, of course, is that the p is in the denominator. One way of handling this, and there are many ways, cross multiplication or inverting both sides. One way of handling this is to clear denominators. Multiply both sides by 4p. So you multiply the left-hand side by 4p, and they just cancel, and you're left with a 1. Multiply the right-hand side by 4p, and we obtain this. Now, of course, the 1/8 times the 4 simplifies. That's just a half. And now you can see that you should just multiply both sides by 2. So you find that p is equal to 2. We didn't have to do that in this case. It was obvious what p was. But in other cases, it won't be obvious. And knowing how to solve this equation will be important. So anyway, we've identified h, k, and p. So we can now determine all of the important things. So as far as graphing a parabola, it's pretty easy. All I really want you to do is the following. I want you to find the coordinates of the vertex and then just open the parabola in the correct direction, up, down, left, or right. So we'll start by writing down the vertex. The vertex is located at h, k. We've already established that, h is 2 and k is 3. So let's put the vertex at 2, 3. And now, which direction should the parabola open in? Well, okay, notice that in our equation, it is the y term which is squared. And when the y term is squared, that corresponds to a sideways parabola, either left or right. So this thing is either going to open to the right, like this, or it's going to open to the left, like this. Now, of course, what determines whether it opens left or right? That's whether p is positive or negative. In this case, we've already shown that p is positive 2, so this thing opens to the right. So something like this. And that's all that I want you to do for the graph. I don't really care how skinny or wide it is, whatever. So that's the graph. Now, let's find the focus, right? So the focus is going to be somewhere in here. The graph always hugs the focus. So where is it exactly? What are its coordinates? Well, just remember that this distance right here is p, which of course is 2. So therefore, this coordinate must be 4, 3. And then as far as the directrix, that the parabola always opens away from the directrix. That's important to notice. See how the parabola opens away from the directrix? The parabola opens away from the directrix. So the directrix here has to be somewhere over here so that the parabola is opening away from the directrix. And once again, this distance right here is also p, right? I didn't draw it to scale, but it's supposed to be p. So this is a vertical line. Its equation is of the form x equals some number. What is that number? Well, because it's 2 units to the left of this coordinate, it's going to be x equals 0. Okay, so that's the end of that problem. One more example, and then we'll be done. So let's do one of these problems. We've seen many of these for other conic sections, but we haven't seen them for parabolas yet. I'll give you some random information about the parabola, and then you try and find the equation. So here's the example. Suppose you have a parabola with a focus at 2, 3, and a directrix at x equals -6. Actually, let me change this. I think I want to change that to maybe -8, 3. Okay, so the focus is at -8, 3, and the directrix is at x equals -6. Let's find the equation of the parabola. So, as always, whenever you're given random information about a conic section and you want to find the equation, you should begin by just sort of plotting this information, just draw a picture. So the directrix is at x equals -6. Look, that is the equation of a vertical line. Important to notice. X equals a number, that's a vertical line. So the directrix is a vertical line, right? X equals -6. Now, where is the focus? Well, the focus is at -8, 3. -8 is to the left of -6, so the focus must be somewhere over here, right? To the left of the directrix. All right, now what else can we do? Well, look, the vertex is halfway in between these two things, right? Halfway between the focus and the directrix. So what are the coordinates going to be? Well, the x-coordinate is going to be halfway in between -8 and -6, so it's going to be -7. And then the y-coordinate is, of course, the same as the y-coordinate here, so that's going to be 3. All right, so that actually tells us h and k, doesn't it? H and k are the coordinates of the vertex. The graph has to be opening like this, by the way, because the graph has to open away from the directrix, and it has to hug the focus. Okay, that's important. The graph should not cross the directrix ever. All right, so we know all the things we need to know to write down the equation except for p. What is p? P is effectively the distance, or it's obtained at any rate, from the distance between the vertex and the directrix, or if you like, the distance from here to here, focus and vertex. In either case, you can see that this distance is certainly 1, right? However, you have to be careful, because even though this distance is 1, remember that p could be positive or negative. And so what I'm arguing here is that p could be 1 or it could be -1. Which one it is? Well, remember what I said. The sign of p, whether it's positive or negative, determines the direction in which the parabola opens. I said at the beginning that if the parabola opens to the left, that means that p is negative. So actually p should be -1, not +1. Be careful about that, right? All right, so now, of course, we have two forms of the equation, right? One where the x term is squared, one where the y term is squared. Which one should we be using? Well, because this is a sideways parabola opening to the left, we should be using the one where the y term is squared. So our general form is going to be x minus h is equal to 1 over 4p times y minus k quantity squared. So that's our general form. Now we just plug everything in. H is -7, so that's going to be x plus 7 is equal to 1 over 4p. P is -1, so 4 times -1. Y minus k, k is 3, so y minus 3, quantity squared. And that's it. I guess you could call that -1/4 and simplify it, but you get the picture. Yeah, so when you're doing these, just, the things to keep in mind are draw a picture. Make sure that you are opening your parabola in the correct way. Watch out for the sign of p. Make sure that you're making it negative if necessary, according to the direction in which the parabola opens. And make sure that your parabola always, hugs the focus, right? It should be hugging the focus, sort of surrounding it, and it should be opening away from the directrix, okay? And just always be careful about whether your directrix is supposed to be a horizontal or a vertical line. Look at the form of the equation. Is it x equals a number or y equals a number? That will tell you whether it's vertical or horizontal. Okay, that is it.